This past May, I was given the opportunity to visit a sawmill.
The Green Diamond Resource Company and the California Redwood Company offered a scholarship, and I ended up being one of the recipients.
They set up a tour of their facilities for all the recipients, presumably so we could learn more about the company that would be helping fund our education.
Before the tour, I had sort of expected to see nothing but a sawmill. I ended up learning a lot about just how multidimensional the company's production really was. The first thing our group did was go off to a redwood forest and receive a lecture from a biologist and a forester. They talked at length about the various methods they used to study the ecosystem of the redwoods. The family-owned company manages hundreds of thousands of acres of forest in Northern California, not only complying with state regulations, but preserving it for future generations. Our biologist talked to us about the aquatic life that lives in the streams and the various methods that they use to count its population. Afterwards, a forester took us into a second-growth redwood forest consisting of redwood trees about 100 years old,
explaining the process in which redwood trees are examined and designated for harvesting.
The next destination on our tour was the nursery in which all the different redwood trees that are to be planted are bred. Our guide told us about how the quality of a redwood tree depends on its age. When a redwood tree dies, the remaining stump will generate a new ring of smaller redwood trees around it that are genetically identical to the parent tree. After a certain period between 1500 and 2000 years, though, the redwood will stop doing this. Thus, it is important when harvesting samples off redwoods to graft, it is established the parent tree is the first generation, rather than being a product of a ring. After samples from a desirable tree are obtained, they are grown in massive volumes in laboratories, really massive volumes. 500,000 trees can be grown at a time. Afterwards, we enter the actual sawmill. Logs are brought in after they have been stripped of some of their bark and cut at each end. The logs are divided into uniform segments by two 6-foot blades.
After traveling down a conveyor belt, the logs are prepared once more before entering the main building.
Each log is scanned, and the computer goes through thousands of iterations of possible combinations to calculate the most efficient way to cut the log and maximize its output.
This is the first place where it actually starts to look like a board. This is our log quad.
The next room we visited was the saw repair room. A machine would run a saw blade through its mechanisms to cut off the damaged tips and replace them with new ones.
A sign made it very clear that we were not under any circumstances to walk on the saws. After that, we viewed a laser, scanned the logs, and first saw them vertically, and after they traveled on a conveyor belt, saw them horizontally. The variety and complexity of the conveyor belts would have made Rube Goldberg proud. Employees were at every step of the process with dashboards full of buttons to regulate and make sure the entire system was running smoothly. Even with how automated the whole system was, workers would still need to manually make sure that all the boards were laying properly in their places. Now that it is in its final form, every board is scanned again, and the computer records its size and quality, and it is graded by a team of professionals. Then the board is sorted and placed into a pile along with other identical boards. Once the boards are stacked, their journey from a log to a plank is complete. The final stop of the tour was to visit the spotted owls. Their population and survival as a species is closely monitored to make sure their habitat isn't threatened by the logging. By luring the owls with food, we were able to see them up close.
They really like treats, as we discovered.